For decades, concerns about climate change have largely focused on rising temperatures, extreme weather, and melting ice caps. However, a less obvious but equally alarming consequence is emerging, one that threatens the very future of space operations. Greenhouse gas emissions are increasingly being recognized as a potential threat to the sustainability of low Earth orbit, as they contribute to the accumulation of space debris and pose challenges for future satellite operations. Recent research published in Nature explores the consequences of rising emissions on the capacity of low Earth orbit to support satellites. The study underscores the risks posed by climate change, orbital debris, and space congestion, all of which could significantly disrupt technological advancements in space. Findings from the research indicate that greenhouse gas emissions directly impact the thermosphere, the atmospheric layer extending from approximately 85 to 600 kilometers above Earth. This region plays a crucial role in satellite drag, which influences whether satellites remain in orbit or eventually re-enter Earth's atmosphere. As emissions increase, the thermosphere contracts, reducing drag on satellites and allowing debris to remain in orbit for extended periods. This reduced atmospheric resistance exacerbates congestion in low Earth orbit, making satellite operations increasingly difficult and hazardous. Projections suggest that by the end of the century, moderate to high emission scenarios could shrink the usable capacity of low Earth orbit by up to 82% at altitudes ranging from 400 to 1,000 kilometers. This would particularly impact satellite operations during solar minimum periods when atmospheric drag is already weaker. Did you know that over 95% of our viewers aren't subscribed to the channel? We totally get it. Life gets busy, and sometimes it's easy to forget. But here's the thing. Subscribing is completely free, and it really helps us keep creating the content you enjoy. So, why not hit that subscribe button and join our community? It only takes a second, but it makes a world of difference to us. Thank you for your support. The thermosphere's declining density, largely influenced by carbon dioxide emissions, slows down the natural process of satellite deorbiting, allowing defunct satellites to remain in space for much longer than anticipated. While reduced drag might seem beneficial for active satellites, it significantly worsens the problem of space debris accumulation. Typically, satellites are designed to gradually descend due to atmospheric drag, eventually burning up upon re-entry. However, as drag diminishes, non-operational satellites linger in orbit, increasing the risk of collisions and complicating the deployment of new spacecraft. The lead author of the study, William Parker from MIT, stresses the urgency of addressing this issue, stating that climate change and space debris accumulation are interconnected global challenges requiring immediate and coordinated efforts. The growing number of satellites in orbit further amplifies concerns about congestion. Currently, nearly 11,901 satellites are operational, with an additional 20,000 pieces of space debris scattered across low Earth orbit. Although the point of no return, known as Kessler Syndrome, has not yet been reached, scientists warn that continued emissions and increasing satellite deployments could bring us dangerously close to that threshold. The rapid expansion of satellite constellations, particularly by companies such as SpaceX, adds to the complexity of space traffic management. Despite advancements in tracking and monitoring technologies, the increasing number of objects in orbit raises the likelihood of collisions. These events could generate even more debris, creating a self-perpetuating cycle that endangers the future of space exploration and satellite-based technologies.